So in last session, we have taken introduction to Synapse and Synapse architecture as part of session 1. So here we have discussed about the introduction to Synapse Analytics Service, Analytics Workspace. What is the advantage of the workspace? You are getting multiple services which are related with BI. So examples for that, you will be getting what is our warehouse environment here? Synapse SQL pool. You can say SQL pool DB. So this is actually the warehouse, data warehouse. The old name for this is Synapse DWH. DWH is old name. Now latest name is Synapse SQL pool D. Addition to this, you are getting your ADF pipelines and data flows and everything. Also, you are getting data lake Gen 2. Simply ADLS, Azure Data Lake Storage, which is Gen 2 you are getting. And also, suppose if you are already a Databricks developer, you have Spark Pool. There is a concept called Spark Pool. If data is more bigger to process our data efficiently with high speed, Spark Pool will be helpful. Okay. Yeah, and also like after that we have discussed about the Synapse architecture.
So does Spark Pool come as a premium subscription or as a normal subscription?
It's normal also available. But completely you cannot configure the number of nodes like Databricks. The basic Spark pool with a single node cluster is available to you. Okay. If you go with the Databricks, you can configure a number of nodes per your cluster. Yeah. Okay. Sir, all of you please go to the mute, sir. Home noise is coming. Please mute. And Synapse architecture. What is the what are the major components in the Synapse architecture? What is the master node here? Master node is called controlling node. The slave nodes are called computing nodes. So how many come? Generally, the controlling node is always one. The computing nodes, multiple. So minimum one and max, that is your choice. Okay, this is minimum one. So you can configure like 10 nodes, 20 nodes, even biggest organizations will be configuring 200 nodes, 300 nodes like that. But as many number of nodes that you are configuring, that you are engaging for your cluster, the charges will be different. Okay, because finally you are paying for the computing cost. Only two costs that you have to pay. One is storage cost, second one is computing cost. So at each node, there is a service which always keep running into that node. That is DMS. Okay. What is the DMS? Data movement service. One node to other node, how data is exported or imported into the different nodes is, there is a service called DMS. Okay. Data movement service. So these services will be keep running. So, and also one more point we have discussed here. In Synapse table, data is stored in the form of distributions. Okay, data is stored in form of distributions. How many distributions per a table? For one table, what is the answer, sir, for this? How many distributions?
60.
60 distributions. 60 distributions. These 60 will be distributed, these 60 distributions will be distributed across multiple nodes during computation. So that final beauty of this synapse is the execution style. MPP, massive parallel process. So advantage of this one is high speed processing that you can achieve, even the table volume is bigger. Generally, sir, we don't face such kind of issues. Really, if table has more than a terabyte of data, when you run a process, time will be hours. That too, if you run a complex process like a sorting kind of process on the terabyte data, if you run it, the time will be even days time also for regular databases. Okay. So where Synapse, because of this MPP features and these distributions and type of distributions and in the backend indexings, the time will be within minutes. What are the previously it was taking for days. Now that is into like less than or near to 1 hour like that. So these concepts we have discussed in Synapse session number 1. Today, let's enter into the Synapse session 2. Types of distributions. And second point, we will discuss about indexes, types of indexes. Because finally, these two things will control our performance. Okay. So types of indexes. These two things we will be discussing today. Now I'm going to talk about distributions. There are basically 3 types of distributions. Number 1, hash distribution. Number 2, round robin distribution. And number 3, replicated distribution. There is a technical word for this replicated distribution, that is a broadcast distribution. So these are the different types of the distributions. So how each distribution will work and when to use what are the recommendations given by the Microsoft Azure, when to use what type of distribution, the related topics we will be discussing. First, I'm going to talk about directly. I am coming to the round robin distribution. After this, I will explain hash. Let me go with the paint. Suppose I have different nodes here. Already, you know, we have a master node, which is called as a controlling node. And remaining slave nodes. These slave nodes simply called as computing nodes. Think that I have only 5 computing nodes over here. And you have 10 records. Suppose the table has 10 records. Let's say 60 records. But these 60 records to be divided into the distributions. What will happen is record 1 will be sent to distribution 1. Record 2 will be sent to the distribution 2. In this way, record 3 will be sent to distribution 60. So not record 3, record 60. The record 60 will be sent to distribution 60. Suppose if you have 100 records. Now what is the distribution style in the round robin style? Record 1 to distribution 1. Record 2 to distribution 2. On the same style, final last record, record 3 to the distribution, sorry, record 60 to the distribution 60. But what about record 61? Record 61 will be coming back to again first distribution. Distribution 1. Record 62, that will be to distribution 2. On that way, the things will happen. For example, I have only 30 records. I have only 30 records here. If you treat distribution as a box, first 30 records will be sent to 30 different distributions. But there is no 31st record. Remaining distributions are empty boxes. That's it. Distribution is there, but there is no occupancy in the space. No records will be there into that one. Got it? It's an empty box simply. So finally, at any cost for a table, you should have 60 distribution at any cost. That distribution can have 0 records, can have more than 0 records. Got it? If you look at, according to the 100 records example, if you look at distribution 1, how many records are there? If you look at distribution number 1, if my table has 100 records, in the distribution number 1, how many records are there? According to round robin, there are 2 records, record 1 and record 60. Understood? On that way, in the uniform order, in the sequence order, the records will be distributed into distributions. Once all distributions completed, again the next record will be coming to the first record. This is style of round robin. Round robin distribution. Okay. That means what is the style? What you can write about it? Records will be distributed in sequence form. After completion of all distributions, of course, you have a fixed count, which is 60. After completion of all distributions, next records will be sent to first distribution onwards. Will be sent to again sequence of distribution. That is the meaning of this. Okay. Next one is, I'm going to talk about hash distribution. Actually, how this hashing will work is, record key will be sent to hash function. A record key will be sent to hash function. Hash function outputs a value. Based on the value, equal values will be sent to a particular. Equal values will be sent to a particular distribution. Okay. That means value 1 is sent to distribution 1. What depends on the output value, that particular record will be sent to a particular distribution. So for this, for example, I will say, suppose my record key is ID, employee ID. At the time of creating table, based on what column the hashing to be applied, you have to decide that column. Suppose the first ID is 101. 101 is sent to hash function. Suppose the hash function value is A1. Think that A1 is sent to distribution 1. And after that, second record is 102. For that, again, hash will be applied. Think that here the result is 8. This will be sent to the next distribution. Look at 103. The hash of 103, but result, the return value of this hashing is A1. Already, if my hash function output is A1, that record is already sent to a distribution 1, so that this 103 output also A1, this also will be sent to distribution 1. For example, I'm going to take another fourth record. The fourth record hash value is again A2. But first A2 is sent to distribution 2. That's why this record also will be sent to A2, the distribution 2. But 105, think that hash of 105 is A3. Is a different output of this hash function, so that it will be sent to again different distribution like this. In this way, at the time of the internal algorithm of hash, you can choose how many number of output values to be produced. But here, how many number of values will be produced? Because I have 60 distributions. That's why 60 values will be produced. You pass any key, the output value, any one value between these 60. Based on that value, one particular unique value will be sent to one particular distribution. If A1 is sent to distribution 1, means A2 will be sent to other distribution. Again, for the next key, if A1 is repeated, again, first A1 is sent to distribution 1. That's why this record also will be sent to that distribution. This is called like a hash distribution. Of course, this hash distribution is not only available in Synapse, in regular databases also, this hash distribution is available. Especially for some specific performance issues, they are using this one. So after completion of next point also, I will be explaining when to use what. So now,
So what happens if the number of unique key records in a particular table are greater than the number of distributions?
No, it doesn't matter. Already I told you, there can be 1 lakh records, sir. But the hash value of any record to be any one of those 60 output values. So that finally what will happen? These 1 lakh, these 10 lakh records or 1 lakh records will be sent to how many distributions now? I have 1000 employees. Look at this. My 101 is my employee, but what is the key? A1. For 103, what is the key? A1. That means as per this, the distribution outcome, that is hash function outcome to be between A1 to A60. Whether I have 60,000 employees, doesn't matter. 60 crore employees, that doesn't matter. Every employee ID to be the outcome of that hash function to be any one of given 60. Understood, sir?
Yeah, understood. But I have a question here. Like if you're using hash distribution and on a big table and trying to use aggregator functions,
yes,
like you're trying to aggregate the values, wouldn't the result be skewed? Because if these are in different distributions, similar records are in different distribution.
Yes, sir.
And we do have limitation on the number of distribution. So wouldn't we be getting a skewed results?
Nothing, sir. Nothing, sir. Because all these are the distributions related with one table only. Think that in the distribution number 1, first employee salary 10,000, next employee salary 20,000, 20,000, third employee salary 30,000. In the distribution 2, other different 3 employees are there, their salary is like this, 60,000 and 90,000 and 10,000. When you apply the query, like select sum of salary. What will happen? This will be executed by one node. This will be executed by one node. The result by the first node is what? 60,000. The result by the second node is what? 1,60,000. So finally, these two independent results will be again summarized. Understood? Where is chance of skewing the values here? Sir, please reply your understanding.
Yep.
Hello. Got
Yeah,
it. In this way, if I have 1 lakh records, suppose easy calculation purpose, I have 60,000 records. These 60,000 records are distributed into how many distributions? 60 distributions. So that each distribution has how many records? 1,000 records. When I run a query, these 1,000 records, that means these 60 distributions will be parallelly computed. From each parallel computation, separate result will be produced. Again, all these results will be collected by other node. Final summary will be produced. Got it? So this is the style. How many records that you have in our table, that doesn't matter, based on the hash. Here in Synapse, the hash will produce only 60 possible outcomes. Okay. So here I will write the same point, the Synapse hash function. Produces 60 possible outcomes. Here there is a interrogative question here. I have only 3 records. Think that 101, 102, and 103. I am applying hash of 101. Outcome is A1. Here hash of 102. Again outcome, think that A1. Here hash of 103. Think that again outcome is A1. If I have 3 records hash function value is same thing, think that A1. Outcome is A1. Now total how many distributions? Total how many distributions? 3. No. Still 60 distributions. But all these 3 records will be available into first distribution. Because outcome is A1, A1, A1. So that first A1, 101 is sent to distribution number 1. Second record also will be sent to distribution number 1. Third record also will be sent to distribution number 1. But there is no fourth record. That's why second distribution onwards, everything will be empty in this special case. That means you can say one active distribution, remaining 59 inactive distributions, because no records in those distributions. When our first record entered into a distribution, then the distribution will come to the active mode. Got it? So I am reversing the same thing. For the first record, hash function outcome is A1. For the second record, A2. Third record, A3. Now, the distributions will also be a different. Distribution 2, the third record will be sent to distribution 3. Depends on the outcome of hash function, a record will be sent to a particular distribution. Equal out all for all the records which has equal outcome, they will be sent to one particular distribution, one single distribution. This is how hash distribution will work out. Okay. Even there are some other advanced massive parallel computing systems are there. At that time, they are using even 500 distributions or 600 distributions like that. At that time, how it has to be configured? The possible number of outcomes to be A1 to A500. But in Synapse, no choice for you, because the max number of distributions is fixed here. That is 60 distributions. You cannot go beyond 60 distributions for one table. Got it? So in this way, the hash distribution will be working. Next, one more distribution, that is replicated or broadcast distribution. Let me clear these things. Replicated or broadcast distribution. All table data will be sent to each distribution. Each distribution of those 60s. An example, here I have a table, that is table 1 has 3 records. These 3 records like 101, 102, 103. In the distribution 1, all the 3 records will be there. In distribution 2 also, all the 3 records will be available. Finally, if you look at distribution 60 also, all the 3 records will be available. That means the same copy of the table is available with each and every distribution. That means 60 replicas per our table data. This is called a broadcast distribution or replicated distribution. But what is the advantage? When to use what? There is a guidelines. What are those guidelines is? The guidelines by the Microsoft, sir. First, I am going to talk about hash distribution. If it is hash distribution, the recommendation for the Microsoft, there are 2 recommendations. Number 1, if tables disk space is more than 2 GB, more than 2 GB. I'm talking about single table. If table data is more than 2 GB, then go for hash distribution. And second recommendation, the second scenario for this hash distribution, when table has more insertions, updates, and deletes, this is another situation. Okay, frequent insertions, frequent updations of the data, and frequent deletions of the data, such kind of activities are there on the existing table, then go for the hash distribution. So these are the 2 guidelines given by the Microsoft to achieve the good performance. And second, there is a other distribution, that is a round robin distribution. Round robin distribution. Round robin distribution use case is only one: to increase loading speed. To increase loading speed into the table, round robin distribution type you have to use. So at the time of creating table only, you will have to choose what type of distribution in the back end that you want. At the time of creating table only. I will show you the complete syntax. If you don't choose any type of distribution, the default one is round robins. Suppose here I am creating a table only like this. Suppose a small table I am creating, a create table. Let's say create table, a demo. Here I have some columns, ID, int, name, varchar, and salary int. This is the general your table creation. If I close this table, like this. Default is round robin. Understand? Default is round robin. But I want to make it as hash distributed table. I have to say with distribution is equal to. I'm saying that hash. But hash based on what key? Hash should be done based on some column. That is key. Then I will say go. This is what my statement here. Suppose if I don't say this with class, with function, if I don't specify any distribution, default is round robin. Round robin is best advantage, especially whenever you are loading data. Especially what we are going to work. Finally, we are going to perform data ingestion activities with ETL style or ELT style. But for big volumes, ELT style is required. Extract data from the sources and load into your round robin distributed tables. After that, perform the transformations for remaining activities. Got it? So finally here, a small point for loading of data, round robin is faster. For querying data, and other crude operations like a creation of a record, reading, updating, deleting, such kind of things. For other crudes, what you call hash distribution is faster. But there is a special case of broadcast distribution. Okay. Or the official word for this one broadcast is replicated. What is the use case of replicated is, suppose I have a table employee. The employee table has how many distributions? Definitely a table should have 60 distributions. But each distribution has some piece of data. That too, these 60 distributions are distributed into different computing nodes to support the parallel process. And there is a table called DEPT. DEPT, I am making it as replicated. This is also having 60 distributions. But each distribution has entire data. Now I am going to apply the joins. Suppose in the employee table, I have columns ID, name, salary, gender, and department number. In the case of department, I have columns department number, department name, and location. I want to join these two tables. Here my query, select, suppose ID, name, salary, gender, department number, department name, location. From left side table is employee, join. Right side table is DEPT. If you want to set, give some alias, employee X, and DEPT alias is Y, where X dot department number is equal to Y dot department number. On that way, I have applied some join. So this is simple my join statement. But every time, whenever I apply a join, Sanjay, whenever I applied a join, what has to be done? Left side record has to be compared with the right side record. That too, this is equi-join, inner join. That means that department 11 should be joining with 11 only, 12 should be joining with 12 only. But employee data is in different distribution. Department is data is in again 60 distribution. But in which distribution that the record number 11 is available, it has to search. Suppose in the first distribution, department 11 is not there, then it has to search for distribution number 2. Still 11 is not there, then it has to search in distribution number 3. In this way, 60 distributions it has to search. It will take a lot of time. That too, in the case of employees, there are 1 lakh employees. But in the case of a department, generally, if you have 1 lakh employees, 1 lakh departments will not be there. Even though 1 lakh employees you have in your company, but number of departments are only 100. Number of departments only 100. 100 departments is a small data. That's why what you are doing, you are keeping these 100 records in every distribution. You are keeping these 100 records in every distribution. Observe this in a picture way. I will explain. Think that this is computing node number 1, computing node number 2. Only 2 node point of view example I am saying. This is, and the first one is employee distribution. Second one is department distribution. Employee distribution, department distribution. I have only 3 departments. The DEPT, I have only 3 departments. Those are 11, 12, 13. So same copy will be available into second distribution also. That is 11, 12, 13. But I have 6 employees. I have 6 employees. First employee is 101. He is from 11 department. Second employee 102 from 12 department. 103 from 11 department. Other 3 employees in the distribution number 2. 104. Department 12. 105. Employee 105. He is from 13 department. Employee 106. Employee 106 is from 11 department. Now, what is the advantage? This is EMP distribution number 1. This is EMP distribution number 2. This is DEPT distribution number 1. And distribution number 2. If I have such kind of broadcasted distribution for the employee, for the department, what is the advantage I am getting, sir? Final, my goal is joining emp.department number is equal to dept.department number. Based on the department number, I want to join the tables. This is what my joining condition. Sir, I am waiting for your answer. So here, one thing. Here I am going to query the data. Whenever I am querying the data, what kind of distribution is recommended for the employee? Think that I am using hash distribution here. But this to join employee data with the departments, under every node, under every distribution, all departments to be available. That's why I have broadcasted it. For the DEPT, I have used broadcast distribution. That means replicated distribution. For employee table, I am using hash. For department table, I am using broadcast. What is the advantage I am getting? My query is this one. My query is this one, where x dot department number is equal to y dot department number. X is alias of employee, y is alias of department. Now my query is this one. Hello, sir, future data engineers, please answer. Ceci, please try. This is case 1. Sir, first record, look at the first record. First record ID is 101, department is 11. 11 should join with 11. Understand? 11 should join with 11. But for this joining comparison, this 11, both are available in, both data is available in same node or not? Got it? Whether it is the same node or different node, it doesn't matter. But whenever it has contacted one distribution, in that distribution, the 11 is available. Suppose second record is 102, 12. 12 is also available in one of the nearest distribution. 13 also available in one of the nearest distribution. For example, I am changing the case, sir. I am changing the case. If my data is like this, suppose in the first, here I am not using broadcast, only 11, 14 departments are available here. Here 12 and 13 departments
Excuse
are
me.
available here. Sir, please go mute, sir.
Yeah, sir, there is a lot of background noise.
Hello. Yeah, if it is not broadcasted, if distribution is a round robin or hash, all departments are not available in single distribution. Think that if I have 4 departments, 11, 14 are in one distribution, 12, 13 are in other distribution. Now look at the second record, sir, which is 102. To join 102, 102 belongs to which department? 12 department. But when to join this employee data with the department, if it contacted distribution 1, in the distribution 1, there is no 12. Then it has to search in distribution 2. Think that in distribution 2 also there is no 12. Then it has to contact distribution 3. On that way, the joining searching time will be bigger. Especially these broadcasted table will be helpful at the time of joining. At the time of joining with parent tables. Got it? See this one. But note important. The joined table should be small in volume. Should be small in volume. Why this caution? Definitely in employee case and department case, I will use this broadcast. Employee, I will keep it as hash. Department, I will keep it as broadcast. What is the reason? What is the reason? Always employees are in bigger in quantity. Okay, maybe I have 1 lakh employees or 10 lakh employees, but in the department, even though 10 lakh employees, I have only 100 departments. My number of departments are less. Definitely, obviously, the department is a small volume. I can go it as a broadcast. For example, let's take an example of Amazon. Customers and products. I want to join these 2 tables. Customers and products, I want to join these 2 tables. Now in this case, definitely customer is bigger in quantity. So here I am going for hash. Can I go products as a broadcast now? Can I go products table as broadcast?
No.
Why?
Number
Because
of products.
Amazon number of products. Amazon number of products is more than customer count. Got it? Their products is also the number of products for the Amazon is big volume. Only for products database, that is multiple terabytes of data. So in this case, you are not recommended to go as a broadcast table. So here also I will be using hash. Understood? I will be using hash only. But come to the our organization, which is Sonar Technologies. In the case of this one, I have students table. Each student is here, product is course. I want to join students and course. Definitely my student count is bigger. Then I will go it as hash. What about courses? Max to max 10 or 20 courses I have. Then small in volume in terms of number of courses, so that I can go it as a broadcast. All of you understood, sir? So finally, you have three types of distributions. One is hash distributed table. Simply, you can say that the table is called as hash distributed table. Round robin distributed table. And finally, replicated table, which is broadcasted table. If you have greater than 2 GB data and also more IO operations, that means more querying on that data, then go for the hash. The round robin table, the use case is for faster nodes. And replicated table, increase performance while joining. That to do, this is for small volume of tables, but not recommended for the big volumes. Especially if you look at Amazon example, customer count is very bigger, products count is also very bigger. You cannot go as broadcast. But how to create your table? Simply same as regular, but additional option you have to say. Create table and give the table name and give the columns. Column 1, column 2, column 3. After that, finally, apply with class. With distribution is equal to. If you want to make it as a hash, just give hash. Based on what column you want to create that hash, based on ID or product ID, whatever the column that you have, you just give it. That's it. If you don't specify any distribution, default is a round robin table. Let me check the chat messages. Okay. All of you understood this. Next, there is other way to increase the performance. That is by creating index objects. Index objects for tables. This is the second phase of activity to increase the performance while querying the data. There are basically 4 types. Number 1, clustered column store index. Clustered column store index. Second one, clustered index. Third one, non-clustered index. The fourth one, table without index feature, that is simply called as heap tables. Heap. Heap means no index. Understand? Okay. What is the advantage? I'm coming to the very basic. All of you, I believe all of you are comfortable with SQL. In SQL, I am creating a table, create table something. Suppose employee, ID int, I am making it as a primary. Name, something. In this way, many other columns. Sir, what are the qualities of ID, sir, here? For the ID, for that ID, you made that ID as a primary key. Whenever I make some column as primary key, internally what happens in the database is one unique index object will be created. One unique index object will be created. If it is unique index object, there are two advantages. Number one, no duplicates. That means duplicates are not allowed. And number two, random access. Random access means suppose you have 1 lakh bank account holders, but you are interested about only your account balance. Whenever you insert your card, by taking input from your by taking card number as input from your device or from your card, from the database it has to retrieve only your record only, that too randomly, not by doing sequential search. So with the unique index object you have two advantages. One is no duplicates, second one is random access of a record based on key. Understood? So this is the major advantage. Similar to this, here you have clustered index. I'm talking first about clustered index. If I create one clustered index based on some column, next onwards randomly I can access the data. Whenever I want 105, record number 105, straight away directly it points to the 105 record, it will retrieve it. Internally, special algorithms like binary tree, binary search, such kind of algorithms will be running in the backend. Okay, so you have to create clustered index when you are interested about. Access single record random. Then clustered indexes are faster. For example, you look at this query set. Select star from EMP. How many rows you are retrieving? All the rows you are retrieving. But you are not interested about all the rows. You are interested about only your employee ID is 107. But in the table, there are 1 lakh rows. Only 107 record only should be retrieved. But 107 is available in which distribution? That index is maintained. That register is maintained by the system. That is when you create clustered index for your table. Got it? For example, if my query select star from EMP, where city is equal to Hyderabad, this is my query. But in the second query, for the second query, this clustered index is not at all helpful, because here in the second query, you are not interested about a particular record. You are interested about all employees who are in Hyderabad. Understood? So here first employee 101, he is from Hyderabad. Second employee from Pune. Third employee is from Hyderabad. Fourth employee is from Hyderabad. Whenever I apply this query, what is the internal execution style, sir? In this way, table has 1 lakh records. Table has 1 lakh records. Hyderabad is 30,000. I applied this query where city is equal to Hyderabad. Sir, online team, please answer, sir.
Maintains through cluster.
Forget about cluster. If there is no any index update, what is the style of execution? First, it will retrieve first record.
Sequential.
Yeah, row by
And
row.
validates the condition. If it is true, it returns. False, it leaves. Then it goes to second record. In this way, record by record, the sequential process is happening. Got it? But I want to improve performance in such cases. On that moment, I have to go with the opposite. Previously clustered, now non-clustered index. I have to create a non-clustered index for that. So this is when indexing based on duplicated columns. Indexing based on the duplicated columns. Suppose you take city, within the city, Hyderabad can be repeated multiple times. Delhi can be repeated for multiple times. It clusters. Okay. That means all Hyderabad it keeps into, for all Hyderabad related record addresses, it will maintain at one pool. Delhi record addresses, it will maintain at one pool. Like that. Whenever you are asking for Delhi records, it will retrieve it in very faster. But some cases, you are confused. At what time, based on what column that you need to create index, you have confused. At that moment, go for clustered column store index. This is similar to Parquet file. There is a special file format called Parquet file. In Parquet, data is stored in columnar storage format. That too with very high level compression. Understand the point, sir? That too data is very high level compression. Because of high level compression, disk space will be saved. Because of columnar store, access will be faster. But index will be maintained for every column. Index will be maintained for every column. That means it is giving you the basic features, index based on every column. That means for every column, separate indexing internally it maintains in the format of columnar style. And second thing, data storage in columnar format. And third thing, high level compression. And fourth thing, the faster access. These features are offered by the clustered column store index. But there is a problem. If table has index objects, loading time will be very big. If table has index object, the data loading time will be very big. That's why to which tables I am going to load the data. For those tables, temporarily or permanently, I want to suspend indexing feature. If my table is not having any index, the index of the table is called heap table. That means, let me write the same statement. If table has index object as indexes, loading time will be big. Loading time will be big. Okay, if table has indexes, loading time will be big. That's why if table doesn't have any index, the table is called simply heap. Heap table. Got the point, sir? So when to use what kind of indexes, all these things we will be explaining in next session. Next session, first, before going for these concepts, first we see the practical demonstration of all these topics. How to create distributed tables and how to create indexes. First, we will see. We will learn practically. Then I will come to how to optimize your performance by the combination of distributions and indexes we will be discussing tomorrow. Okay. Yes, sir. Already yesterday session I have shared to you. Just in the chat. So this session, maybe today or tomorrow, I will share. Mostly today. Okay, sir. Let's see tomorrow.
Sir, one question.
Yeah, please, sir.
Sir, so as of now, still we are more of towards in the Azure Data Factory, right? We are covering most of the things in Azure Data Factory. So how depth we are going?
Sir. Your name I don't know. Point number one.
Okay, my name is Venkat.
Yeah, Venkat.
So my question is,
ADF full in-depth, sir.
okay, ADF full in depth.
Synapse full in-depth, sir. Data lake full in-depth, sir. Okay.
Okay.
Everything you just treat as a separate entity. Okay. Finally, we will be learning like the integration of all these things. So ADF will be a separate, Synapse will be separate. After completion of Synapse, for your batch, I will come to the ADF. Okay. To learn ADF, Synapse is not required. To learn Synapse, ADF is not required. Both are independent components.
Okay.
So finally, you will be learning like how to combine all the things like this. So by the end of this week, before Pongal festival, the Synapse will be completed. After Pongal festival, we will be working with ADF, especially in the 815 batch.
Okay, so from when we'll start the synapses, sir?
Synapse yesterday only started, sir.
Yes, sir.
Yesterday only Synapse started.
Yeah, I think yesterday is given
session.
the okay, given the kind of demo.
Yesterday
for
first
that.
session, today second session of the Synapse. Tomorrow we are going to the practical part of the Synapse. Okay.
For ADF for after Pongal will start.
Yes, sir. Sir, for you guys, a small suggestion: don't treat ADF. Don't treat it as Synapse. First, now I am teaching Synapse. Just learn Synapse first. Don't think that I'm going to learn ADF. Why Synapse is he is teaching like that. Without Synapse, you cannot enter into the industry. You cannot perform your ADF roles. What are the things that are required to the industry, that are required to you, that I am teaching? Please learn that. Give me freedom to design the curriculum and first what to teach, next what to teach. Please don't try to control me in such a way. So for this batch, first I am going with Synapse. For the previous batch, first I went to ADF. Now, though the previous batch is coming to Synapse into this session. For you guys, Synapse is the first subject. Maybe for the next batch, Azure SQL will be the first subject. Maybe for the next batch, Azure Data Lake will be the first subject. On that way, the cycle will be repeated with 4 components with the ADF, Synapse, Azure SQL, not normal SQL, Azure SQL, and ADLS. Sir,
are we covered most of the syntaxes in the Python in the synapses?
Sir, in Synapse, only how to use Python, where to write Python, I will teach. But I don't teach Python. This is not Python course.
Okay.
Got it. This is not Python course. Suppose somewhere some customized logic you want to write, where to write, one simple example I will show you.
Okay.
I am not here to make you Python developer. Already I am a Python developer, sir. I am a data scientist also. But this course is not meant for that Python. Okay. Okay, sir, all of you. Let's see. Let's see tomorrow.
Okay, thank you.